So, um, with this bell ringer, pay attention to where the variable is located. Um, whether it's in the top or in the bottom. Sometimes you can make life a little bit easier with the ones that are in the top than you can with the ones that are in the bottom. But either way, cross multiply and divide, right? So we got 2x equals, what's 6 times 9 is 54, right? And divide both sides by 2. You get x equals 27. So now with this one, you have the option of doing it the same way. 3n equals 50. Just be aware 50 and 3 don't have any factors in common, so it's okay for you to just leave it as 50 over 3. It's okay for this to be a fraction like this. All right? All right, same thing here. Let's cross multiply and divide. We've got 6r equals 16. Let's divide both sides by 2. And we notice 16 and 6 both have a factor of 2 in them. So let's divide the top by 2 and the bottom by 2. 16 divided by 2 is 8. 6 divided by 2 is 3. So we get a final answer of 8 over 3. Last one. We're going to cross multiply here again. We got 8p equals 3 times 5 is 15. Divide both sides by 8. What do we get? P is 15 over 8. Do they have anything in common? No, they don't. They're relatively prime to each other, so we're going to leave it as just 15 over 8. And there's our final answer. Okay, any questions about this? What are we doing today? We're going to use trigonometric ratios to solve for a missing side or a missing angle. How are we going to do this? We're going to identify which ratio to use and then solve for the missing value. Why? Well, this past week we talked about some shortcuts, some ways that we can do these problems a little bit easier if we have the right information. Yeah, we talked about if we had 2 out of the 3 sides, we can find the third one using the Pythagorean theorem. If we know that we've got a special type of triangle, we can use that those ratios that we talked about on Wednesday, Thursday, to figure out the missing sides with the 45, 45, 90 triangles and the 30, 60, 90 triangles. So what we're going to talk about today is, okay, well, what happens if you don't have that? What happens when you can't do that? So today you will need to have a scientific calculator on hand because some of these things cannot be done without one. If you go onto like the Google homepage, you can pull up the calculator from there, and that works just fine. The only thing to be very, very aware of is that regardless of how your calculator is, you want to make sure that you are in degree mode. All right, and you can test that with if you type in sine of 90, you should get 1. If you don't get 1, you're not in the right mode. We'll talk about what these things are in a second, but you can, if it doesn't specifically say like DRG or something like that, that's where you would want to make sure to check. But either way, we're going to go through it together. So let's talk about these 3 trigonometric ratios we're going to talk about. Now, this is sort of an intro to trigonometry. This is not all the things by any stretch of the imagination. Our little unit on trigonometry will take roughly two weeks total. And yeah, you're not gonna have to deal with all the stuff you're gonna have to deal with trigonometry when you get to pre-calc. This is going to be a very brief overview of what trigonometry is and how to use it. All right. So let's go forward and let's talk about the three trig ratios that we are going to be discussing: sine, cosine, and tangent. Now, these are known ratios. They are actually, if you've got a calculator, they're programmed in. All the values are programmed in. So you go through, like I typed in the sine of 90 degrees. It doesn't matter, like I could type in some random thing, whatever, and I will get a value. This value, if you notice here, sine, right, represents the ratio of the opposite leg, the leg that's opposite to the angle that we're talking about, to the length of the hypotenuse. That is to say, if I know that this angle is 54.2553 degrees, then if I take the measurement of the opposite side and I divide it by the measurement of the hypotenuse side, this is the value I will always get. A 54-degree angle always has the side and the side lengths in a certain proportion. A 92-degree angle is going to have all the side lengths in a certain proportion. A 21-degree angle is going to have all the side lengths in a certain proportion. That's what these are talking about. The specific proportionality of the sides is generated by these. So it's not something that you have to like think about. These are like, you don't have to sit here and know how to like intellectualize these right now. Well, you'll talk more about this in a much more rigorous sense when you get to pre-calc. But for geometry, we are coming at these from the perspective of, if I have an angle, if I have any angle here on a right triangle, I can use the fact that this angle is some amount, and then I will know what all the sides could be based on what the ratio is. So just like your 45, 45, 90, your 30, 60, 90, they're all in a certain ratio. Same thing with all the other ones. It just so happens that unlike the 45, 45, 90, and unlike the 30, 60, 90, the ratios that we get are ugly, usually. Usually they're pretty ugly. So when we go through and we want to find either the sine or the cosine or the tangent of a certain angle, we choose a specific two sides to base it off of. For the sine, we base it off of the ratio of the opposite leg to the hypotenuse side. For the cosine, we represent that ratio and base it off of the adjacent side, the one that's actually on the angle is one of the arms, and the hypotenuse side. And then the tangent of an angle is created by the opposite side divided by the adjacent side. All right? So when I tell you that this process is not designed for you to like spend a lot of time thinking, this is probably one of the only times in this class where, at least for now, I'm going to expect you to kind of know these by rote. That is to say, I'm going to expect that you have these memorized. What does that mean? Well, so I'm going to expect that when you hear the word sine, you think opposite over hypotenuse. When you hear the word cosine, you think adjacent over hypotenuse. When you think of tangent, You think of opposite over adjacent. Now, there's an old mnemonic device. It's been used for a very long time. And it basically just helps you to remember, like, what I'm about to tell you isn't the reason for anything. It's just a way for you to remember. It's like kings play cards on fat green stools for remembering the taxonomy groups, right? Kingdom, phylum, class, order, family, genus, species, right? Or my very excellent mother just served us 9 pizzas. Well, the pizza part doesn't come in anymore since there's no Pluto, but Mercury, Venus, Earth, Mars, Saturn. Right, yeah. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto from back when I was a child. And Pluto was still classified as a planet before they realized there were like a whole ton of other similarly sized bodies in the outer solar system that were as big, if not bigger, than Pluto. And so they decided, well, let's, rather than having 57 billion planets to have to remember, let's just cut it off at 8. Same idea. This is going to help you to remember which one is which. So we call it SOHCAHTOA. And when, basically it just, what does that stand for? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So if you can remember SOHCAHTOA, it's going to mean that you have a lot less thinking that you have to do because you'll have everything in your brain and you'll be able to just sort of unpack it a little bit easier. So let's go ahead and move forward. So here what we're going to want to do is I want to find the value of the sine, the cosine, and the tangent ratios for angle T. So the first thing I want to do before I do anything else is make sure, see, because this was written from the perspective of angle A, right? So the opposite side's over here, the adjacent side's over here, and the hypotenuse side is over here. I want to make sure that this triangle looks exactly the same. Well, here's my angle T, right? So the opposite side's over here, the adjacent side's over here, and the hypotenuse side is over here. So everything looks good so far. So let's do this. Let's write everything out. I'm going to put this down so I can remember. So what's the sine of angle T? Opposite over hypotenuse. So that's 8 over 17. What's the cosine of angle T? It's adjacent over hypotenuse. So that's 15 over 17. And then what about the tangent of angle T? Well, tangent is opposite over adjacent. Opposite over adjacent. So that's 8 over 15. Pretty simple, right? It's just writing it out. Identifying which is opposite, which is adjacent, which is hypotenuse, and then filling out what needs to be filled out. We want to write the sine, cosine, and tangent ratios for angle G this time. All right. So the first thing that we should recognize is the fact that, hey, G is up here. It's not down here where it's supposed to be, right? Remember that our whole point Our whole point is we want to be looking at this angle. Now, at some point, some of you are going to be able to just do this by looking at it, and that's great. I'll be honest with you, I'm still not there, because it's, you know, it's one of those things where we have trouble a lot. So I'm just going to take this, I'm going to flip it around. This is, now I have G in the spot that it's supposed to be. Well, what's opposite of G? 15. What's the adjacent side here is 8, and then the hypotenuse is 17, right? So now that I've successfully taken the triangle and flipped it, now I can do my sine, cosine, and tangent just like before. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So opposite. Right? Opposite, adjacent, hypotenuse. So the sine of angle G is opposite over hypotenuse, 15 over 17. Cosine of angle G, adjacent over hypotenuse, right? 8 over 17. And then the tangent, opposite over adjacent. So it's, I mean, it's simple. It's just reading off the triangle. So don't feel like you have to like burn out your brain trying to do these. They're designed here. They're designed to be very, very brainless. This should be very simple to do once you have the mnemonic device down. Yeah? So now we want to actually solve for something. I'm going to do a couple examples with this one. Now, we're at the point here now where we have to have a calculator in order to do this properly. So make sure you've got either a calculator in a separate tab that is set to degree mode, or you've got a scientific calculator next to you, like or on your phone or whatever, as long as it's in degree mode. Degree mode is necessary because we use degrees in geometry. Eventually, you'll talk about other units of angles, but for right now, we are only concerned about degrees. All right, so again, is this set up so that the angle is in the right spot? No, so let's do that. I'm going to redraw this so that the angle, that the right angle is here on the right, and the angle that we care about is here on the left, 54 degrees. Well, now where does everything else go? W is over here, opposite, right? And then a hypotenuse is up here. So now let's look. We've got, here's the opposite, here's the adjacent, and here's the hypotenuse. And I look up and I say, all right, well, I don't have the adjacent, so I know I can't possibly be using cosine or tangent. Those are out because I don't have the right info to use those. I have to use sine. So look, we're saying the sine of what's the angle here? 54 degrees equals opposite over hypotenuse. Opposite over hypotenuse. So now you can go through and you can cross multiply. Now you see why we did this in the bell ringer. We're going to cross multiply. We get W equals 17 times the sine of 54. So one other thing I want to point out, this sine of 54 right here, this thing, this is already a number. You put it into the calculator, it already knows what the sine of 54 is supposed to be. Whatever that number is supposed to be, that's what that is. It's a programmed number in your calculator. Now, the other thing we need to be careful of then is how we enter this into the calculator, because we just want to say this number times 17. We don't want to do anything else with that. We just want to do, hey, take whatever this is and multiply it by 17. So here, let's bring out our friend, the calculator here. And we just want to enter this into the calculator. 17 times the sine of 54. And the calculator is literally going to do all the rest of the work for us. So if our answer was supposed to be 17 times the sine of 54, then the answer that they're going to ask for, because it says to the nearest tenth here, we've got, I'm going to write it out. That's what the calculator gave us. And one other thing I want to just sort of say is it's important that you take a step and actually physically write this out, especially when we're starting out, because when it gets to the point where I'm actually physically grading you by hand, if this answer is not right and I don't see this, like, because maybe you accidentally type something wrong in the calculator, right? So if you don't write out this step, then I don't know that you were correct, right? And then you'll probably get no points as opposed to most of the points. You know what I mean? But so they want it to the nearest tenth. Remember, the nearest tenth is one decimal place like this, 13.7, and then the rest of it. So when we round to the nearest tenth, we look at the digit after. Is that a 5 or above? That's a 5, so yes. So we round up. This 7 goes up to the next number, 13.8. Normally there would be units like for the length of the side. We don't have that for this. All right, let's do this exact same problem here together. I'm going to take this, not that. I'm going to take this. Hopefully it'll let me take just what I've written. I'm going to squish it down just a little bit. I'm going to move it off to the side. And we're going to do the exact same idea. First thing we're going to do is we are going to redraw this triangle here. And just like we did before, I want to make it all look the same. Right? Our angle needs to go here in the bottom left corner. So now let's label our info. So here's the angle 28. W's in between that and the right triangle, right angle, and then 1.0 is over here. I don't know why they chose to do 1.0. That seems like a lot of work to write an extra decimal place in there, but who knows? So notice we don't have the hypotenuse this time. So what's the only one that does not have a hypotenuse? Well, sine uses the hypotenuse. Cosine uses the hypotenuse. So it's tangent, right? So we're going to use the tangent. of 28 degrees, opposite over adjacent, 1.0 over W. Cross multiply, just like we did last time. So once again, we're going to multiply. We get W times this number. Remember, this is a number, right? This is its own number already. Don't mess with it. This is already a thing. Don't mess with it. So W times tangent of 28 degrees equals 1 times 1 is 1, right? Well, now we want to get W by itself. So we're going to take the number tangent of 28 and divide it over to the other side. So what am I left with? I'm left with W equals 1 over the tangent of 28 degrees. And that's what I'm going to try and do in my calculator here. And once again, see how I wrote it out? I wrote out all my work here so I know if I did it right. 1 divided by tangent of 28 degrees. That's not what I wanted to happen just now. Let's try that again. 1 divided by tangent of 28 degrees. Close parentheses. And look what I get. I get that number. That 1.8807264665 number. That is my answer. 1.8807264665. And once again, they say to the nearest tenth, so that's what we're going to do. Nearest tenth is the nearest one decimal place. So we're going to look at the second one. Is that bigger than 5? Sure is. So we're going to round this up. 1.9. So now let's go ahead. I've got one more for you to try. Same idea. You're going to go ahead and do this on your own. Go ahead. Okay, let's go over this. Same idea, same exact problem, just different numbers. So here's our triangle. Remember, we want the angle over here so that we can do our work. Well, where is the W? The W is right here. Where's the 4.5? The 4.5 is here. So now we look. There's opposite, adjacent, hypotenuse. Well, what are we working with? Are we working with sine? Are we working with cosine? Or are we working with tangent? Well, let's look. We have no opposite. So SOHCAHTOA, we can't use sine. We can't use tangent. We have to use cosine, right? So cosine of 33 degrees equals adjacent over hypotenuse, W over 4.5. So let's cross multiply. This W looks weird. It's not much better. Let's just fix that completely. W over 4.5. There we go. So now once again, we're going to cross multiply and divide. We're going to end up with 4.5 times the cosine of 33 degrees. Once again, remember this cosine of 33, that's already set. Don't touch that. It's a number. All right. So we do that, and we're going to pull out the calculator, type it in, and what do we get? .5 times cosine 33. And again, make sure you're in degree mode. If you're not in degree mode, this is going to be Not so fun to do. You'll come out with the wrong answer. This is our answer. 3.7740175556. That answer is what we get. So what is that? Let's do 3.7740175556. And they want it rounded to the nearest one decimal place, the nearest tenth. So we look, that's a 7. Well, that's bigger than 5, so we're going to round this 3.7 up to 3.8. Okay? Alrighty. Now we're going the opposite way. What does that mean? Well, here, what I want is I want the value of that angle. How's that going to work? Let me show you. So first things first, let's redraw this because this is backwards from what it should be, right? Trying to find that angle. I'm given this here is 6 and this here is 10, right? So let's write it out. Am I using sine, cosine, or tangent here? Well, it's opposite and hypotenuse. SOHCAHTOA, so sine, right? So the sine of this number we're trying to figure out is 6 over 10. Well, how do I deal with that? If only I could get x by itself. Well, we can. So basically, you know how multiplying is the same as dividing, adding is the same as subtracting, they're inverses of each other. Squaring and square rooting cancel each other out. Exponentials and logarithms cancel each other out. All those different things cancel each other out. Well, we've got something to cancel out for this, and we call it the inverse sign. So I'm going to take the inverse sign. This is the symbol that your book normally uses. I don't like this symbol, but we're going to use it anyway. So the sine and the inverse sign cancel out. What we're left with is inverse sine of 6 over 10. This is what's going to go into our calculator. All right, so let me show you. You'll notice on your calculator where the sine button is, if you go above it, there'll be a little sine -1 button. So here we hit the second because that's what makes us do the blue things. Second, sine, and see how I get sine -1 right here? That's what I'm looking for. And I want to take sine -1 of 6 over 10. And what this is going to give us is this is going to give us the angle that has the ratio 6 over 10. It's not going to be a nice number, but it's going to be what we get. 36.86989,765, right? Now they say to the nearest degree, that means the nearest whole number, right? Because a degree is a unit, right? So what is this? 36.86989,765. And we're going to round it to the nearest degree, the nearest whole number. Is this number bigger or equal to 5? Yes. So this is going to get rounded up to 37. And then we actually do get a unit here, degrees. So make sure you put the degree measure. All right. So we already have the ratio. We just need to take the inverse sine, throw it into the calculator, and then we're good. All right. Your turn. Give this a try. Same idea, just different numbers now. Okay, let's go ahead and do this one. So again, it's not in the right location. We want to find the measure of angle X. That's up here. We don't want it up here. We want to redraw it so that it looks like it's supposed to. Put the X down here. Well, now where's everything else? Well, the 15 is right here. The 20 is up here. So again, which one are we looking at? We've got adjacent and hypotenuse, so we're looking at cosine, ladies and gentlemen. So the cosine of the thing we're trying to find is 15 over 20. Now, some of you are going to be like, oh, yeah, I can simplify that. That's 3 over 4, right? You're putting it into the calculator anyway. What do you care? Don't worry about that. That is doing a lot of extra work for no reason, right? Don't do extra work when you don't have to. Take the inverse cosine of both sides. And then this is what's going to go into our calculator. So let's hit the buttons and type in the stuff. Remember, inverse cosine, we use the second function, make sure we get the inverse. It better say cosine -1, otherwise you know that it's not right. 15 over 20. Just like that. And there we go. What's our answer? 41.40962211. Let me write that down. 41.40962211. And again, they want nearest degree. That's the nearest whole number. We look at that 4. Is that bigger than 5? No. So this whole thing, we drop it. We just say 41 degrees for our answer. All right. So that's the basics of what we're doing. There's also a couple extra included problems that are sort of application-y. I mean, they do a bunch of applications, but like in this book, they have a whole extra section of a couple problems dedicated to a very specific way of applying this. And they're called angles of elevation and depression. And what do we do with those? So the only thing you need to know with regards to the angle of elevation and the angle of depression. Angle of elevation is when the point of view in question is looking upwards. So this angle from the girl to the hang glider here is the angle of elevation. I shouldn't say girl, woman. From the woman to the hang glider is 38 degrees, and it's an angle of elevation because the woman, she is looking upward. Now, on the other hand, if we are taking the perspective of the person on the hang glider here, they're looking down at the woman, so this is an angle of depression. So we look at whose perspective we're coming from. Is the person looking up or is the person looking down? The thing to be very, very clear about is that between two people looking at each other, the angle of depression of the person looking down, the angle of elevation of the person looking up are the same because of alternate interior angles and parallel lines, right? These lines, the horizontal lines here are parallel. So this angle and this angle, alternate interior lines, are congruent. So they may give you the one up here, but you need the one down here. That's up to you to notice. But if you know that this is 38, you know this is 38. If you know this is 52, this is 52. All right? So we're going to just discuss, because this is not like a big thing necessarily. This is more just, hey, is I mean, like, it's not even about knowing is it an angle of depression or angle of elevation, but they're going to ask you some of those types of questions. I just want to prime you for them. So let's start with the man in the balloon. If he's looking down to the base of the mountain, this angle 3. This is an angle of depression. Likewise, if the person who's down here at the bottom of the mountain is looking up at the dude, get an angle of elevation. Same thing here. Whatever thing this is, sort of looks like a bird, but maybe it's a plane. Does that mean it's Superman? I don't know. So the guy looking up here at Superman, angle 2, angle 2 is an angle of elevation because the guy in the balloon here is looking upward. Likewise, here's Superman up here. He is looking downwards. So this is an angle of depression.